A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed a space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.